Today, we are going to learn an important concept in complex analysis called residue. Residues help us evaluate complex integrals, especially using residue theorem. This is widely used in mathematics, physics, and engineering. Before we are going to see how to find the residue of the given function, we will see some formulas. I gave only the four important formulas for finding residues. The first three formulas for simple poles, and the fourth one, which is for the pole of order m. Okay, so the first one, residue of f of z at the pole a is equal to limit z tends to a z minus a into f of z. And the second one, residue of f of z at the pole a is equal to limit z tends to a h of z divided by k dash of z. And the third one, residue of f of z at the pole a is equal to limit z tends to a g of z. And the fourth one, residue of f of z at the pole a, which is equal to limit z tends to a g power m minus 1 of z divided by m minus 1 factorial, which is equal to g power m minus 1 of a divided by m minus 1 factorial. The first one, if the given function which is having a pole which is simple, and the second one, the function which is having the pole is also simple but which is in the form of h of z divided by k of z. And the third one, if the function having the pole which is simple and also in the form of g of z divided by m minus 1, is z minus a. So that is g of z, which is equal to f of z is equal to g of z divided by z minus a. Apart from the z minus a, the remaining we called as g of z. And the fourth one, if the pole of order m, we have to use the fourth formula. Okay, so now we will see some problems. The first problem, find the residue at z is equal to 0 of 1 plus e power z divided by z cos z plus sin z. Solution. So first we have to consider the given one as f of z is equal to 1 plus e power z divided by z cos z plus sin z. Given z equal to 0 is a pole of order 1. Okay, if the given pole which is simple, hence we have to use any one formula in the first three. Okay, so we can use the first one or the second one or either the third one. Easily we can get the residue of the theorem. So far better we have to use the second one, because the given function which is of the form h of z divided by k of z. Okay, so we know that the residue of f of z at the pole A, which is equal to limit z tends to A, h of z divided by k dash of z. So here, A, what is A? The given pole. So consider the given pole which is A. So A equal to 0. So h of z, what is h of z? 1 plus e power z, which is h of z, and z cos z plus sin z, which is k of z. So in this formula, we have to know what is k dash of z. Therefore, from k of z, we have to find k dash of z. So that means differentiate one time with respect to z. So k dash of z is equal to, so here we have uv, okay? So we know that how to differentiate uv. So the formula is what? u dv plus v du. So differentiate z, we get 1, and cos z is a constant, therefore cos z into 1 is cos z, and keep z is a constant, then differentiate cos z, we get minus sin z, therefore minus z sin z, plus the differentiation of sin z, which is cos z. Okay, so now we have to substitute that h of z and k dash of z in this formula. We get the residue of f of z at the pole 0 is equal to limit z tends to 0, 1 plus e power z divided by cos z minus z sin z plus cos z. So now substitute that z is what? 0. So we get 1 plus e power 0 divided by cos 0 minus 0 sin 0 plus cos 0, which is equal to 1 plus e power 0 is 1 divided by cos 0 is 1. So 0 sin 0 is 0. So 0 into 0 is 0 plus cos 0 is 1. So which is equal to 1 plus 1, 2. Again it is 1 plus 1, 2. So 2 by 2, which is equal to 1. So hence the residue of the given function at the pole z equal to 0 is what? 1. Second problem. Find the residue of 1 divided by z square plus a square whole square at z equal to ai. Solution. So already they are given the pole z equal to ai. So it's a simple, based on the given function z equal to ai is a pole of order 2. Okay, so I'll tell you how to find that one. So first we have to consider the given function, which is f of z equal to 1 by z square plus a square whole square, and the denominator is z square plus a square is whole square. Take that's equal to 0. So we get z square plus a square is equal to 0. Z square is equal to minus a square. Z is equal to plus or minus ai. So we have two poles, z equal to ai and z equal to minus ai. So both the poles z equal to ai and minus ai are the order 2. But here they are asking to find the residue of the given function at the pole z equal to ai. Therefore, we have to consider z equal to ai only. So z equal to ai is a pole of order 2. So out of that 4 formulas, the fourth one, if the order which is more than 1, that means it is not a simple pole. Okay, so the given problem is having the pole which is order 2, hence we have to use the fourth formula. So we know that the residue of f of z at the pole A is equal to limit z tends to a g power m minus 1 of z divided by m minus 1 factorial. So here a is a pole, that is a equal to the given pole which is ai, and f of z, what is f of z? 1 by z square plus a square is a whole square. We rewrite this, we get 1 by z plus ai whole square into z minus ai whole square. So which implies g of z is equal to, so the remaining, okay, z minus ai whole square, leave this one, we get the remaining which is g of z. So g of z which is equal to 1 by z plus ai whole square. That means z plus ai whole power minus 2. And the order m is equal to 2. So which implies m minus 1 is equal to 1. So if replaced in the formula m by 1, we get g power 2 minus 1. So 2 minus 1 is 1. So g power 1 of z, that means g dash. Suppose if it is m equal to 3, 3 minus 1 is a 2, that means g double dash. If m equal to 4, that is 4 minus 1, that is 3, g triple dash, that is the meaning. That means we can differentiate 3 times, but here we have m equal to 2, so 2 minus 1 is 1, so g dash. So g dash of z divided by 1 factorial, right? So g dash of z means you have to differentiate g of z with respect to z by 1 time. So that is g dash of z. So g dash of z is equal to, so z plus ai whole power minus 2. So we know that if it is z power n, that is n z power n minus 1, right? So if you differentiate, we get minus 2 z plus ai whole power minus 3. So which is equal to minus 2 divided by z plus ai whole power 3. So now we have to substitute this in the formula. We get residue of f of z at ai is equal to limit z tends to ai g dash of z divided by 1 factorial, which is equal to limit z tends to ai, where g dash of z is what? Minus 2 divided by z plus a whole power 3. 1 factorial is 1. Okay, so which is equal to, replace z by ai, we get minus 2 divided by ai plus ai whole power 3, which is equal to minus 2 divided by ai plus ai 2ai whole power 3, and which is equal to minus 2 divided by 2 power 3 is 8, a power 3, I power 3 is what? Minus I. Okay, so which is equal to, if you cancel 2 and 8, we get 1 by 4, and a power 3 minus minus cancel, and I, if it is 1 by I, right? 1 by I, which is equal to minus I. So minus I by 4 a power 3. So which is the answer for the given problem. So similarly, we have to find the residue of many problems. Okay, so many problems by using the remaining formulas. Okay, thank you.